Okay, a few more problems on slope. Here we see a graph and a couple points on it. We can find the graph of this line using our slope formula. So it'll be y2 minus y1 for x2 minus x1. And you can pick whichever point you want to call the first point. You could say, if you want, this could be point 1 and this could be point 2. So we're going to take negative 2 minus 2 over negative 4 minus 1 and simplify. So we get negative 4 over negative 5, and that's 4/5. So there's the slope. Notice it is a positive number, which we expect because the line goes up to the right. So 4/5, notice that the y changes by these many units, which is 4 units, as the x changes by this many units. Oops. This is 5 units here. 1, 2, 3, 4, 5. 4 over 5. Okay. Now, how do you know when lines are parallel? Well, they have the same slope. So, and when they're drawn, when they're graphed together, parallel lines, for instance, in here we'd see a line that does something like that. Oh. Yeah, that's maybe a little bit. Let's see. I think everybody knows what parallel lines look like, but let's draw one anyway. For instance, one that starts here and comes up approximately like that. Okay, that would be parallel to this other one. Okay, now perpendicular lines, that's another story. Let's draw a couple of those in here. Do the best I can with this. Okay, so I've got a line here. We'll say this is line 3, and here's line 2, and here's line 1. Line 3 is perpendicular because it forms this right angle in here. When they form right angles with each other, they're perpendicular. So what's unique about this situation when this happens is that slopes of perpendicular lines are negative reciprocals of each other. So for instance, in this case, we have slope for line 1. We already calculated that is 4 over 5. Well, line 3 over here, its slope will be negative 5 over 4. And you can kind of see how they just sort of reverse roles. The change in the x becomes a change in the y and vice versa. So that's how you know you have perpendicular lines. Now, if you're given two equations, let's see what that looks like. So let's say you have two equations in this form. Let's say here's one, and here's another one. Without graphing these, you can tell if whether or not they are perpendicular or if they're parallel. you have to determine the slope of each one. So let's go ahead and do a little work with that. For this one, we need a couple ordered pairs, x, y. So I'm going to let x be 0. When I do that, y is going to be 2 over 5. If y is 0, you can see from the equation, x will be a 2. So the slope here will be 2 over 5 minus 0 over 0 minus 2. So if you do the math here, you're going to end up with negative 1 over 5. Okay, slope for this line, again, we can do this. Find a couple ordered pairs. I'm going to set x equals 0. That means from the equation we get y equals, well, here, I won't do all that in there. When x is 0, we end up with this. So y is negative 3/4. When y is 0, you get 20x equals 3. So x is 3 over 20. Now, if you do the math on this, you're going to get slope is negative 3/4 minus 0 over 0 minus 3 over 20. And this will end up being negative 3/4 times negative 20 over 3, which simplifies to positive 5. If you compare this number to this number, notice that they are negative reciprocals. They're opposites and they're reciprocals. So yes, these lines are perpendicular. If we graph them, we could illustrate that, but we won't on this video here.